Hi, in this video we're going to introduce our section on finding zeros of polynomial functions. And we're going to use what's known as the Rational Zeros Theorem or the Rational Roots Theorem to list out the potential rational zeros of a polynomial. So exciting. So the rational zeros, sometimes called the Rational Roots Theorem, is going to provide us with a way of listing all of the rational zeros of a polynomial. So recall that the zeros have many aliases: solutions, roots, x-intercepts, and a rational zero is one in which those values are rational numbers. So in other words, it's one integer over another integer, or it's a decimal that terminates or repeats. So when looking at polynomials for rational zeros, we're going to focus on the constant term. Remember, that's the one without the x or the variable, and then the leading coefficient, the number in front of the variable with the highest power. And your possible rational zeros are going to be it's going to be a list of all the factors of the constant term divided by all the factors of the leading coefficient, and we'll consider the positive and negative of each of those. So it'll probably make a little bit more sense when we see it actually in action right now. So example 1, let f of x equal 2x to the fourth plus 4x cubed minus x squared minus 6x minus 3. We're going to list out all the potential rational zeros of this function. In other words, for all the values of x that are solutions to this equation equaling 0, or all the x-intercepts we could have, we're going to list out all the ones that are potential ones that are rational numbers. So we're going to look at the factors of the constant term. Our constant term is 3. Just don't worry about the pluses and minuses just yet. And the factors of our lead coefficient, which our lead coefficient is 2. So the factors of 3 are 1 and 3. Prime numbers are really nice in this section. And then the factors of 2 are going to be 1 and 2. And what we're going to do is we're going to generate a list of all the possible numerator values over all the possible denominator values, keeping in mind that each one could be the positive or the negative root of that. So first up, we have 1 over 1, which is just 1, and just add the plus or minus afterwards. And then we have 1 over 2, which is 1/2, and then add the plus or minus afterwards. So with this 1 in the numerator, we have 1 over 1, which is 1, and 1 over 2, which is 1/2. Now let's move over to the next value in the numerator, 3. 3 over 1 is 3, and we'll put in the plus or minus symbol as well. And then 3 over 2 is 3/2, and then we'll put in plus or minus there as well. So of all the zeros or x-intercepts of this function, the ones that are rational, or at least could be zeros that are rational numbers, are 1 and -1, 1/2 and -1/2, 3 and -3, and then 3/2 and -3/2. So again, this is just a list of possible or potential rational zeros. Not every number in this list is going to be a zero of our function. So we'll look at how to do that in future videos. So that about does it for this video. Thanks for watching. I'll see you